Hey there, folks. Welcome back to our channel. Today, we're diving into a fascinating topic. How will the universe end? Now, there are several theories out there, but let's focus on the most popular ones. First up, the Big Crunch. Picture this. The universe expands, then contracts, and finally, collapses back into a single point. Next, the Big Freeze. The universe continues to expand, eventually cooling down and becoming too cold for life to exist. Then, there's the Big Rip. The universe expands so much that it eventually tears everything apart. Finally, the Big Splat. The universe contracts so much that it forms a black hole, eventually collapsing into a singularity. The ultimate fate of the universe is one of the most profound and intriguing questions in modern cosmology. Scientists have pondered this mystery for centuries, and recent advancements in physics and astronomy have provided several plausible scenarios for how the universe might meet its end. These theories, grounded in observations and mathematical models, explore the interplay of dark energy, gravity, and the fundamental forces shaping our cosmos. 1. The Big Freeze Heat Death. The most widely accepted scenario for the universe's end is the Big Freeze, also known as heat death. This theory is rooted in the second law of thermodynamics, which states that entropy, a measure of disorder in a system, tends to increase over time. As the universe continues to expand, galaxies, stars, and planets will drift further apart. Stars will exhaust their nuclear fuel and fade into black dwarfs, leaving the cosmos cold and dark. In this scenario, the universe's temperature will asymptotically approach absolute zero. Without energy to sustain motion or life, the universe will become a vast, silent expanse of dead matter. Even black holes, the remnants of massive stars, will eventually evaporate through Hawking radiation, leaving nothing but a faint, uniform glow of low-energy particles. 2. The Big Crunch. Big Crunch is an opposing theory to the Big Freeze. It suggests that the universe's expansion, driven by dark energy, could eventually reverse due to the pull of gravity. If the density of matter in the universe is sufficiently high, this gravitational force could overcome the expansion, causing the universe to contract. In this scenario, galaxies would collide and merge, temperatures would rise, and matter would compress into an increasingly dense state. The universe would shrink back to a singularity, the same state from which it began during the Big Bang. This cyclical model of expansion and contraction has fascinated scientists, though current evidence suggests that dark energy makes the Big Crunch less likely. 3. The Big Rip. Big Rip posits a catastrophic and dramatic end to the universe. This theory is based on the idea that dark energy, the mysterious force driving the universe's accelerated expansion, would become increasingly powerful over time. If dark energy's strength grows without bound, it could overcome all other forces, tearing apart galaxies, stars, planets, and even atomic structures. As the Big Rip approaches, galaxies would fly apart, stars and planets would disintegrate, and eventually, even subatomic particles would be ripped asunder. The timeline for this event depends on the nature of dark energy, which remains one of the biggest enigmas in cosmology. 4. Vacuum decay. Another unsettling possibility is vacuum decay, a scenario rooted in quantum field theory. The universe exists in what is called a false vacuum, a stable but not entirely permanent state. If a quantum fluctuation were to create a bubble of true vacuum, it could expand at the speed of light, obliterating everything in its path. Inside this bubble, the laws of physics and constants of nature might differ from those in our current universe, making it incompatible with life or matter as we know it. The process would be instantaneous and unstoppable, though the probability of such an event occurring is extremely low over cosmic timescales. 5. The Big Bounce. Big Bounce is a cyclical model suggesting that the universe might not end permanently. Instead, it proposes that the current expansion phase could be followed by a contraction similar to the Big Crunch and then another Big Bang. This cycle of birth, death, and rebirth could repeat infinitely. While the Big Bounce provides a hopeful perspective on the universe's longevity, it remains speculative. Observational evidence, such as the dominance of dark energy, currently supports perpetual expansion rather than cyclical behavior. 6. The black hole era. In this theory, the universe will enter a black hole era after stars have burned out and galaxies have dissipated. Black holes, which are the remnants of massive stars, would dominate the cosmos. Over trillions of years, these black holes would slowly evaporate through Hawking radiation. Eventually, even the largest black holes would disappear, leaving a dark and empty universe. Observational challenges understanding how the universe might end involves grappling with the unknowns of dark energy, the true nature of gravity, and the behavior of quantum mechanics on cosmic scales. Observations from telescopes like the James Webb Space Telescope and particle physics experiments at the Large Hadron Collider continue to provide insights into these mysteries, but much remains speculative. Philosophical implications. The end of the universe is not just a scientific question but also a philosophical one. It challenges humanity's understanding of time, existence, and the meaning of life. Some see these scenarios as a reminder of our fleeting place in an ever-changing cosmos, while others view them as opportunities to appreciate the present moment. Conclusion. The universe's ultimate fate is a profound mystery that continues to inspire curiosity and awe. Whether it ends in a big freeze, a big crunch, a big rip, vacuum decay, or another scenario entirely, the journey to uncover the truth is as important as the answer itself. As our understanding of physics and the cosmos deepens, so too will our appreciation of the universe's complexity and beauty. So, there you have it. These are some of the most intriguing theories about how the universe will end. Thanks for tuning in, and don't forget to hit that like button and subscribe for more mind-bending content.